Gaia and Hubble have traced the Milky Way's first major collision to a dwarf galaxy swallowed nearly 12 billion years ago. This is Fascinating Frontiers, episode 165. The two observatories combined proper motion data from Gaia with deep imaging from Hubble to identify stars that once belonged to a dwarf galaxy accreted early in the Milky Way's history. The remnant stars now occupy the galactic halo and show distinct chemical patterns and orbital energies that set them apart from later accreted populations. This event is the earliest large-scale merger yet confirmed and occurred when the Milky Way was still assembling its disk. The combined dataset also reveals how the incoming galaxy's stars were dynamically heated and mixed over time. Follow-up spectroscopy of additional halo stars is planned to refine the mass and orbit of the original dwarf. The Milky Way's stellar halo stretches across roughly 150,000 light-years, yet most of its stars arrived in a handful of ancient mergers rather than forming in place. One dwarf galaxy swallowed 12 billion years ago contributed a population now spread over a volume comparable to the distance between Earth and the galactic center. Yet those stars occupy only a few percent of the halo's total mass. When the dwarf fell in, its orbital energy was converted into random motions that puffed the stars into the extended halo we see today, much like dropping a compact ice cube into a swirling pot of soup and watching the fragments disperse. The chemical signatures, lower iron and higher magnesium relative to Milky Way disk stars, still tag these interlopers even after billions of years of mixing. We can map their orbits with Gaia's micro-arcsecond precision, but the exact mass and internal structure of that original dwarf remain uncertain because later dynamical heating has erased the cleanest orbital clues. The open question is whether similar early mergers delivered the seeds of the galaxy's oldest globular clusters, or whether those clusters formed separately before being captured. From reconstructing the galaxy's distant past, we turn to hardware preparing for its own historic firsts in the near future. NASA's Nancy Grace Roman Space Telescope is scheduled to lift off within the next 14 days on a Falcon Heavy. The observatory carries a wide-field infrared instrument designed to conduct a large-scale exoplanet census and dark energy survey. A new podcast episode outlines how Roman will detect thousands of planets via microlensing and directly image young Jupiters around sun-like stars. Integration and testing at Kennedy Space Center are complete. Launch preparations continue at Cape Canaveral. While Roman looks outward to planets and cosmology, another European weather satellite is finishing its own final checks on the ground. The second Meteosat third-generation imager satellite finished propellant loading and moved into final integrated testing at Europe's spaceport. Once in geostationary orbit, the satellite will deliver higher-resolution imagery and lightning mapping for European weather services. Liftoff remains scheduled for 27th August aboard an Ariane 6. Ground teams are now verifying thermal and electrical interfaces before encapsulation. The mission continues the transition to the MTG constellation that will operate through the 2030s. From satellites heading into steady operational orbits, we shift to a Starship that spent nearly a month drifting at sea. Recovery teams guided the Starship vehicle to a location off Christmas Island following nearly a month adrift in the Indian Ocean. Engineers are now boarding to inspect thermal protection tiles and structural integrity before the vehicle is towed back to Starbase. The extended sea trial provides data on long-duration exposure to salt water and wave loading. Analysis will inform future recovery procedures for reusable upper stages. No immediate timeline for return to Texas has been released. Remember, we covered Starship development yesterday, and today's sea trial moves that work forward by delivering direct measurements of how the upper stage holds up after weeks in a marine environment. After long-duration hardware testing at sea, we look at new infrared views of a familiar planetary nebula. The James Webb Space Telescope observed NGC 2392 in near and mid-infrared wavelengths, revealing fine dust structures and ionized gas in the nebula's face-like appearance. Earlier Hubble images showed the outer envelope. Webb's data penetrate deeper to expose previously unseen knots and filaments. The observations help refine models of how planetary nebulae disperse heavy elements into the interstellar medium. The data were released as part of an ongoing program studying evolved stars. Additional filters are scheduled for later this year. From nebular chemistry in our own galaxy, we moved to a surprising mineral find on the surface of Mars. Perseverance identified corundum, the mineral that forms rubies and sapphires, within a rock whose texture suggests shock metamorphism from ancient impacts. Most previously sampled Martian minerals trace to volcanic or aqueous processes. This find points to a separate high-pressure history. The detection was made with the rover's Pixel and Sherlock instruments during a traverse across the crater rim. Scientists will compare the composition with laboratory-shocked terrestrial samples. Further drilling is planned to assess how widespread such minerals may be. From surface mineralogy on Mars, we turn to new high-resolution data on one of its moons. During its March 2025 Mars encounter, the Hera spacecraft obtained high-resolution images and spectra of Deimos that are now being used to model possible impact events on the Moon. The data show surface features consistent with ejecta from larger impacts on nearby Phobos or Mars itself. Mission teams are integrating these observations with numerical simulations to constrain the timing and energy of past collisions. The results will feed into planning for future Phobos-Deimos sample return concepts. Additional analysis is expected in the coming months. From satellite encounters at Mars, we shift to a comet that split in two over the past 6 months. Ground-based telescopes tracked a comet that divided into two components over 6 months, recording changes in brightness, separation velocity, and dust production. The observations allow reconstruction of the fracture event and subsequent outgassing that widened the pair's orbit. Fragmentation models suggest the split occurred near perihelion when thermal stresses peaked. Continued monitoring will determine whether either piece survives the next orbit. The study provides a rare real-time view of cometary disruption mechanics. From active comets in the present, we look back to a historic discovery made during a solar eclipse. On August 18, 1868, astronomers Pierre Janssen and Norman Lockyer independently recorded a bright yellow line in the sun's spectrum during totality that did not match any known element. Lockyer proposed the line belonged to a new element he named helium after the Greek sun god. The identification remained the only noble gas first found in space rather than on Earth. Laboratory confirmation came decades later. The anniversary highlights how eclipse spectroscopy opened the study of stellar composition. From historical spectroscopy, we move to modern planetary defense modeling. Researchers modeled the use of a nuclear device to alter the trajectory of an asteroid detected only months before impact. The simulation shows that a standoff detonation could impart sufficient impulse while minimizing fragmentation risk if the body is larger than a few hundred meters. The work examines variables including yield, standoff distance, and asteroid rotation state. Current planetary defense roadmaps still prioritize kinetic impactors for longer warning times. Further studies will assess detection thresholds needed to enable such options. From planetary defense concepts, we turn to commercial imaging contracts for upcoming missions. Intuitive Machines will provide spacecraft and operation support for the Eagle VSWIR hyperspectral imaging mission. The contract covers integration of the visible to shortwave infrared sensor and mission-unique avionics. Launch is planned within the next several years on a rideshare opportunity. The data will support agriculture, mineral mapping, and climate applications. Work begins immediately at the company's Houston facility. From new commercial missions, we recognize long-running government research programs. Engineers at Glenn Research Center conducted icing, emissions, and propulsion tests aboard research aircraft for more than 50 years, validating designs that later flew on commercial and military fleets. Data collected in actual cloud and atmospheric conditions complemented wind tunnel results and reduced development risk. The program logged thousands of flight hours across icing research, alternative fuels, and boundary layer studies. Many findings remain embedded in current certification standards. Archival reports are being digitized for public access. From established research contributions, we turn to congressional discussion of space-derived benefits. Senator and former astronaut Mark Kelly stated that technologies developed for spaceflight have directly contributed to terrestrial medical treatments that save lives today. He referenced closed-loop life support systems and remote diagnostics now used in hospitals. The remarks came during congressional discussion of the agency's budget request. Kelly emphasized that continued investment sustains both exploration and applied benefits. No specific funding figures were released in the statement. From public advocacy for NASA funding, we close with analysis of classified spending trends. The analysis shows that recent increases in Space Force spending have concentrated in classified programs, missile warning architectures, and command and control systems. Unclassified line items grew more modestly over the same period. The report examines obligation rates and contract types across the past 5 fiscal years. Authors note that visibility into classified accounts remains limited. The findings will inform upcoming authorization debates. New data continue to refine our picture of how galaxies assemble and how hardware performs in orbit. Keep an eye on additional Roman Space Telescope integration updates ahead of its Falcon Heavy liftoff. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Hera Network. Links in the show notes. And before you go, this show is part of the Hera Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Tesla Short Time, your daily deep dive into everything Tesla. Find every show free at neranetwork.com. Want the written briefing with source links? Each show keeps a summaries page on neranetwork.com. Scannable, dated, and free. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly